So here's a question. When you have some data series, which one has the highest correlation coefficient? Probably it seems like this is an easy question to answer. So let's have a look at some data. So here we have two series, Series 1 and Series 2, basic XY series in both cases. And we put the correlation coefficient in at the bottom. These are calculated with the standard correl function in Google Sheets and would be very similar in Microsoft Excel. So which is the better one? Well, if we just look at the numbers, Series 2, 0.84, looks like it's the better series, and therefore one would give that the highest ranking. And then Series 1 would be lower and given a lower ranking. Now we see this all the time. When we look at data, we just simply take an analysis, do the calculation, come up with a number and say, okay, well, the number looks good, so let's use that. But is that really true? So this is why it's important to look at the data, eyeball it, and see whether that's true. So let's look at the charts of the data. Firstly, we'll look at Series 1. So here's Series 1 showing a nice linear trend line. All the points are nicely randomly spread on either side of the trend line, and that looks pretty good. So we would expect that Series 2 should look something like that, but with the points more tightly aligned to the line. Well, there's Series 2. Very, very different. What we see is that most of the data concentrated in this little area here, and there's a single outlier point here which appears to be anchoring the trend line, and when we do the resulting correlation coefficient, it gives us that much higher number. Now we can see that this is probably not a good set to rely on, because if we redo the chart but by excluding this outlier, we'll see something very different. So here is Series 2 plotted without the outlier. So now we can see that the data is indeed randomly scattered on each side of the trend line, but the trend line is essentially flat. In other words, there is no correlation between the data between X and Y. So a single outlier in this case generated a high correlation coefficient. And the question you'd have to ask yourself is that outlier a real data point that makes sense? Or is this just a poor piece of data that's due to an error, a randomly poor experimental data point? In any case, it would seem to be that if you look at the data and say that there's just one outlier that generates a trend line, this is really not giving you a good correlation between the data points, and it should be discarded. So when we come back to the question, which has the higher correlation coefficient? Series 1, it has a good correlation of 0.79, but with Series 2, even though it looked like it had a good correlation of 0.84, in fact is probably a very dubious proposition indeed in terms of correlation, as there is no real relationship between the data points, between the X and Y values, and therefore should be discarded. And I would therefore select Series 1 as the better of the two. So that's a common problem that we can see a lot in analyses, where without looking at the way the data presents, you can make errors that can be avoided. So the take-home message is, look at your data before trusting it.